Welcome to this YSL tutorial. In this video, we're going to cover how to use the Application.InputBox method in Excel VBA. We'll start the video with a quick reminder of the basic generic InputBox function and explain some of its limitations. Then we'll show you how to avoid those limitations by using the Application.InputBox method instead. We'll explain how you can set the return type of that input box, and also how that type of input box automatically validates user input, which saves an awful lot of time and effort doing that yourself. Towards the latter half of the video, we'll explain how you can get that type of input box to return different bits of information. We'll explain how you can return a formula, how you can return a reference to a range of cells, and finally, for the most complex example, how you can return an array of values and then loop over that array to do something useful with it. So let's get started. In a previous video, we've looked at how you can use a basic input box to allow users to enter a value which your program can then use. Here's a quick reminder of how they work. I've created a quick simple subroutine which has 3 variables, and I've let the user to populate those variables by entering values into input boxes. So for example, I can say film name equals, and then call the input box function. I can fill in the single compulsory parameter called prompt. I'll tell the user to enter a film name, or a flim name as I've typed it there, film name. And then I can use the value returned by the input box to populate a cell perhaps. So I could say, for instance, range b2 dot end xl down dot offset 1,0 dot value equals film name. So just to quickly run the subroutine to show you what it does, it displays the input box. I can enter a film name. When I click OK or hit enter, that value will be entered into a cell. And there it is. So that's the basic principle of how simple input boxes work. Now, although this basic type of input box is fairly simple to use, it does have a number of limitations. Firstly, the data type returned by this type of input box can only ever be a string. So let's say next I want the user to populate the film date variable. I could say film date equals input box, and then open some brackets and say enter a date for the prompt. Just before I close around brackets, can you see here at the end of the tooltip, it says as string, meaning that this input box function will always return its value as a string. So we want to work out what will happen if we try to enter a value into that input box and try to populate a date variable. Just before I do that, let's make a quick copy of this line so we can populate the correct cell. So I'll say range b2 and xl down offset 0,1 value equals film date. So now I'm going to run the subroutine. And I'll see a film name input box. I'll type in the same film name, gravity, and then I can enter a date. Now, as long as what I enter into this input box can be interpreted as a date, VBA is quite forgiving about things like this, although technically the input box will return that value as a string. Because I'm trying to store that string in a date variable, VBA will automatically coerce it into a date data type. So VBA uses a technique called implicit data type conversion. If the value you're returning is one data type, but it can be converted into another one automatically, VBA will take care of that for us. So if I click OK here, that will work. If I look back at the spreadsheet, I've got the film naming in again, and I've got the film's release date in the correct cell as well. The problem with this technique, however, is what happens if the value you enter into that input box cannot be interpreted as a date. If I run the subroutine again, I'm just going to go for the same film name one more time, and then type in something which clearly isn't a date, and cannot possibly ever be converted into one. If I click OK, I simply get a runtime error. So that's the first limitation of this basic type of input box. There's no way to control the data type returned, and that can lead to runtime errors. The other main limitation of this type of input box is that if you want to enter a value into it, you have to manually key it in. You have no other choice. So for example, if I want to populate the film length variable, let's say I want to populate film length by displaying another input box, and this will be enter the length. And again, remembering that the input box will return a string, I need to make sure that I type in a valid number in order for that number to be stored correctly in this integer variable. Then I can quickly copy this line of code again and paste it in and change the offset to 0,2 to make that equal to film length. Okay, so if I run the subroutine now and I enter the same film name again, gravity, and then I put in the same release date, 12th of the 12th, 2013, and then if I wanted to enter a number here for the length of the film, what if I could already see in the background there was a number that I wanted to use again? What would be really nice would be if I could click on that cell to read in that cell's value. But unfortunately I can't do that. This type of input box is an example of what's called a modal dialog box. So what that basically means is that while this input box is displayed on screen, I can't interact with the application in the background at all. So I have to manually key in the value. So that's the second main limitation of this type of input box. What we're going to move on to now is show you how to use a different type of input box, one that's specific to Microsoft Excel, which will solve all of these limitations and give us much more power when we ask users to enter values. The other type of input box that you can use in Excel VBA is actually a method of the application object. So to demonstrate how that one works, let's create a quick new subroutine called ApplicationInputBox. And what we're doing here to start with is something very similar to what we started with the previous example. We'll have a variable which will store a film name as a string, and I'd like to ask the user to populate that using the ApplicationInputBox. So again, I can simply say film name equals, but this time, rather than just saying input box, I'm going to say application.inputBox. And yes, believe it or not, this does actually return a different type of function. So if I open some round brackets, you'll see a similar, although not identical, list of parameters. We've still got a prompt, which has to be a string, so I could say enter a film name. But can you see there is no specified return type? There's no as string at the end of the parameter list here. The interesting thing is there is an extra parameter here called type, which we will come back to in a moment. I'm going to leave the type parameter empty to begin with. And if I do that, then by default, this input box will return a string of text. So if I can do that, and then I'm just going to copy the line from the previous routine, just to save a bit of time, not because I'm lazy, honest. And then I'll run the subroutine again, and it will essentially do exactly the same job. The input box looks a little bit different. You can see the buttons are in a slightly different place, but it essentially performs the same role as this in this basic example. So if I say gravity again, why not? Let's be consistent, and then click OK, and we'll see that that value gets entered into the next cell available, just as though it was a standard basic input box. Now the thing which makes this kind of input box more interesting is all to do with that final type parameter. So just before we move on and start writing more code, I want to quickly mention a little bit about how that type parameter works. I'm going to use the object browser to demonstrate this, so I'm going to go to the View menu and choose Object Browser, or you can just press F2 on the keyboard as well. Just quickly, first of all, I'm going to look at the globals class on the left-hand side, and scroll down a little bit on the right-hand side to find the original input box function. So once you've found it in the list, there it is. What I can do is show you down at the bottom here, it says input box and it returns a string, as we saw earlier. And you can see that this is a member of the VBA object library. So what that means is no matter which Office application you're programming in, you can always use this basic input box function. Now the other example we're looking at now, the application input box, is tucked away inside the application class. So if I select application here, this references the Excel application, of course. And if I scroll down the list on the right hand side now, I'll find another instance of the input box, which is essentially a method of that class. So if I select that input box, you get the updated list of parameters, and you can see that this is clearly a member of Microsoft Excel. So this style of input box can only be used in Excel VBA. What I'd like to do is see a little bit more information, so I'm going to right click on the word input box and choose help to launch the help system. So you can see in the list of parameters here, it explains that the type parameter specifies the return data type of the input box, and that's something that we can't do with the basic input box. It also mentions that if you miss out this argument, then it returns text or a string, and that's exactly as we've just used that input box in our small example. A little bit further down the page, it shows you that the values for the type parameter are essentially numbers, and the number dictates what kind of information you will get back from the input box. So if you set the type parameter to be equal to 0, you'll get a formula. If you set it to 1, you'll get a number, and so on and so on. Unfortunately, there's no specific value for returning a date, so we can't use this type of input box to help us with entering a date correctly. What we can do is use it to help us enter a number correctly. So for the next example, what we'll do is use an input box to return the film length, but we'll make sure that that input box can only accept a number. So let's close down the help system and close down the object browser to get us back to the module, and we'll create, or in fact copy, the film length variable to start with, and then we'll create the input box that allows the user to specify what that film length is. So to display an input box which only allows us to enter a number, what we're going to do is say film length equals application.InputBox, and then open some round brackets, and we need to pass in a value to the prompt parameter and also to the type parameter. So let's say the prompt is enter a length or enter the length. And then to get to the type parameter, I've got two choices. I can either type in a stupid number of commas until I actually get to that parameter, which looks horrible, or better is we can use something called named parameters. So what that means is simply putting the name of the parameter before its value. So for instance, for the prompt parameter, I'd say prompt : equals enter the length. Then to move on to the type parameter, I can type in another comma there at the end, and then enter the word type : equals. Let me just scroll the screen across so we can see this in one single screen width. So the type, if you remember, the type to enter a number was the value 1. If I close the parentheses now, that will display an input box which only allows us to enter a number. So, having done that, all we need to do is populate the correct cell. So let's cheat again. No, it's not cheating. I keep on telling myself it's not cheating. Just a copy and paste from the previous routine. And then that subroutine now should allow us to enter a number into the input box. So let's give it one quick test to make sure that it works as intended if we do sensible things. So I'm going to enter the word gravity here again, and then I'm going to enter the length as, I'll just type in the number this time. Click OK, and this should just work as normal. So just as though the previous simple input boxes were being used. What makes this really interesting though is what happens if you try to enter a value into this input box which isn't a number. So let's try to do that. I'm going to run the subroutine again. By pressing F5, I'll enter the same film name. I'm nothing if not consistent. Click OK, and I'm going to try to type in something which clearly isn't a number. When I click OK, here's the beautiful thing. This type of input box has built-in validation. So if you told this dialog box that it can only return a number, and you put something which isn't a number into it, it shows you a simple validation message box. So I can't possibly move on until I enter a valid number now, which is just absolutely wonderful. With the simple input boxes, you would have to code all of this validation yourself. So that's what makes this type of input box so absolutely brilliant. The other slightly less obvious thing that makes these type of input boxes so useful is that they're non-modal. So I mentioned previously that when you display the basic input box you can't interact with Excel in the background. Well, with this kind of input box you can. So if I run this subroutine one more time, rather than typing in the film name and typing in the number this time, what I'm simply going to do is click on a cell which contains the value I want to enter. So if I click on cell, for instance B16, it reads in a reference to that cell into the input box. If I click OK, then I can do the same thing for entering the length, and I can click on a number here. Let's click on the 93. Okay, so that feeds in the reference to cell D18. And when I click OK and then return to the spreadsheet, you'll see that those references to cells have been converted into the values of those cells, one being a string and the other being a number, and those values have been entered, which is so much more convenient than having to type everything in yourself. So those are the two main advantages of using the application input box. The fact that they're first of all validated for the correct data type, and secondly that you don't have to always manually key in a value, you can select cells to feed in the contents into the input box directly. Now I mentioned earlier that the type parameter doesn't allow us to set a data type as a date, which is a bit of a problem for us if we want to enter a date. So one way to sort of get around this is to rely on the fact that all dates in Excel are actually just fancy formats for numbers, basically. So what we could do here is if I copy the film date variable from the previous routine and paste that in again, and then I'm going to say film date equals, and I'm just going to copy this line here, which sets the type or the return type of this input box to be a number. I'm going to change the prompt to say enter a date. And I might put in a quick bit of information to help the user with what format. I'm going to say dd/mm/YYYY. So that sort of helps to explain to the user what value to type in or how to type in the date. So again, I'm just going to copy the line from the previous routine, which will populate the correct cell. And then let's run the subroutine to see what happens. So if I enter a film name again, I'm going to enter gravity, click OK or hit enter. I'm going to click on a cell reference this time to read in the film's runtime rather than type it in myself because I'm feeling a bit lazy. And then for entering a date, here's the great thing. Although technically we're entering a number, even if we type in a date in a specific format, as long as it can be interpreted as a date, Excel will recognise that as a number and enter it in the correct way. So if I click OK at this point and then return back to Excel, you'll see that the value's gone in and formatted as a date. Again, that's been cast implicitly into the correct data type because we're storing it in the date, or a variable with a date data type. So really the fact that it comes out formatted as a date is all down to the data type we've used here. Now the great thing about using this application input box is that, again, if we type in something which is not recognised as a valid date, if I run the subroutine again, I'm going to click on a cell to populate the name, and I'm going to click on another cell to populate the length. If I type in something which clearly is not a date, either a piece of text or even something which looks like it should be a date but actually isn't, so let's say for example, I don't know, the 30th of February 2013, which is not a valid date, if I click OK, I'll get the same validation for the number input box. So it helps you, although you can't change this message unfortunately, at least you get some sensible validation that prevents you from continuing until you enter the correct value. So let's change this back again to 12/12 2013 and click OK, and now everything works perfectly again. So we've seen some of the basic data types that this input box can return, essentially strings and numbers. What I'd like to do now is move on to some of the more interesting things you can get it to return. And we're going to start by looking at how to return a formula. So just before we start writing the code, let's have a quick look at how that would work. A quick way to get to the help page for the input box is to actually just click on that word and press the F1 key on your keyboard, and that'll launch the context-sensitive help system, which takes you directly to the correct place. So again, looking at the type parameter, what we need to do is tell it to return a formula, and to do that we need to set the type parameter to be equal to 0. A little bit further down it says that if the type is 0, the input box returns a formula in the form of text. So although we're returning a formula, we need to be able to store it in a string variable. So what we can do is close down the help system, and let's begin a new subroutine. I'm going to call it simply enter a formula, keep it nice and simple, and then we'll declare a variable in here called dim myFormula as a string. What we can then do is say myFormula equals application.inputBox, and then open some parentheses, and the prompt will be enter a formula, and then the type, of course, will have to be 0. So type : equals 0. Alright, so that allows us to build a formula in the input box. What we need to do now is work out what we do with the formula once it's been created. All I'd like to do is put the formula into a cell on the worksheet. So let's just have a quick look at Excel and pick a cell where we're going to enter the formula. I'm going to pick cell G2, why not? So if I go back to the VB editor, what I can do there is say range G2 dot, then there are a couple of different properties that I could use here. I could just say dot value equals, and then my formula. And what that would do is put the contents of the formula as a string of text into that cell. If you have a quick read of the input box help page, however, Microsoft recommend not using the value property, they recommend using the formula local property instead. And that's to take into account differences in the language settings of the computer that the code's being run on. So instead of using value, we're going to use formula local instead, as that's what's recommended. So I can simply change value to the formula local property. Okay, so having done all of that, I'm just going to run the subroutine, and what I'm going to do to begin with is write a really simple calculation that is going to say D3 plus D4. I could carry on, I could add more plus symbols, and I could build just a complete calculation just as you would as though you were entering this manually into a cell in Excel. But if I click OK at this point, and then have a quick look back at the spreadsheet, I'll find that that cell displays the value, which displays the answer basically of the cell, but it also contains the formula, which means that if I change any values here, then of course the contents of the result of the formula will change automatically, just as it would had you enter that manually in Excel. So that's the basics of entering a formula into an input box. You can use the type property or type parameter, set that to be equal to 0, and then store the result of that input box in a cell. We can make this example a bit more complicated by asking the user to enter a function rather than just a simple formula. So let's say we wanted the user to enter a sum function which will total up some of the film runtime in minutes. What we could do is help the user out by starting the sum function for them in the input box. And to do that we can use the default parameter. So if I head to the end of the type parameter and type in a comma, what I can do is look for the default parameter, and I'm going to put in default equals, and then open a set of double quotes and say equals sum open brackets before you then close the double quotes. So the default parameter sets what's in the input box before the user types something in. So when we run the subroutine now, we will see that the input box gets populated with the start of the sum function. Now it's important that you click after the sum function there to make sure that you don't just overwrite what was in the input box. Then all I'm going to do is get the user to select a bunch of cells, so I can click and drag on cells and it will read in the full range that I've asked for. I haven't quite finished entering this function yet because I haven't finished adding the closed round bracket. But the great thing about this input box, again, we saw it was validated for when you're entering numbers. It's also validated for when you're entering a formula. If I click OK here, the input box will recognise that I haven't finished entering the formula yet. So if I click OK, I can finish that off by closing the round brackets and then click OK. And if I switch back to Excel quickly to see the result, there we go, there's the sum function entered into that cell, and of course if any of these values change, the result in cell G2 will update as well. We could extend this example yet again by asking the user which cell they want their formula to end up in. And we can use the input box to actually return a reference to a range object. If I click on the word input box and press F1, just so that you can see in the help system again, if I use set the type parameter equal to 8, it tells me that you can return a cell reference as a range object. So if I close that help system down, what I'm going to do is declare another variable. I'm going to say dim formula cell as a range. So this allows me to store a reference to a range object. What I can do then is, after I've asked the user to build the formula itself, I can say set formula cell. I've got to use the keyword set here because a range is an object, not just a simple data type. So we've created videos on both simple data type variables and object variables, which are part of this series as well. So if you're not confident with how these work, those videos are certainly worth a watch. But if you're confident, what we're going to do is carry on, say set formula cell equals application.inputBox, open parentheses, let's have the prompt set to, prompt colon equals, choose formula cell, followed by a comma, and we need to set the type, colon equals, to the number 8. So that returns a reference to the range that the user selects. What we can then do is say, rather than range g2.formulaLocal, what we can do is replace range g2 with a reference to our formula cell. So I say formula cell, followed by a full stop, just so you can see the IntelliSense will still appear. It gives you the full list of all the properties and methods of a range object. So, having done that, let's run the subroutine one more time. And I'm going to build the sum function again. I'm going to select a smaller range of cells this time, close round brackets, and then I'm going to click OK. Now I'm going to be asked to choose the cell that I want my formula to go into. So I can click on a cell in the background, G5, click OK, and hopefully we should see, if I switch back to Excel, that the result of the formula has gone into the cell that I selected earlier. So that's how you can get the input box, or the application input box, to return a reference to a range object. Set the type parameter to be equal to 8. When you use the application input box to return a reference to a range, it doesn't just have to be a single cell, it can also be a block of cells. So what we'll do is write another quick subroutine that allows the user to choose a range of cells to copy, and then chooses another cell that they can paste the data into. So we're going to say sub copy data, and it's going to have two variables, dim copy range as a range, and also dim destination range as a range. We'll ask the user first of all what block of cells they want to copy in the first place, and we'll do that by saying set copy range equals application.inputBox, open some brackets. Now the prompt is going to be asking the user to choose cells to copy. And again, we need to set the type parameter to be equal to the number 8. That allows us to return a reference to a range. Once we've done that, we'll ask the user where they want to copy the cells to, and we'll do that in a similar way. We'll say set destination range equals application.InputBox, where the prompt will be something like choose destination. Let's say choose destination cell. So we're going to just pick a single cell, and then we'll set the type parameter again to be equal to the number 8. All we've got to do then is apply the correct method to the correct object. So we're going to say copy range dot copy, and then there's an optional parameter of the copy method in Excel that allows you to specify where the cells will be copied to. So I'm going to put the destination, or set the destination equal to the destination range. So simple as that. If I run the subroutine, what I can do now is pick a block of cells to copy. So let's just pick a few of these cells here. Click OK. Now I have to choose where to start pasting the data into, or where to copy it to. So I could pick, for instance, another cell on sheet 2 perhaps. Let's pick a random cell on sheet 2 and click OK. And when I do that, the cells will be copied. Just to quickly check back into Excel, what we should see is on sheet 2 a copy of that range of data. So there's again how you can use the application input box to allow users to select a range of cells. Now there's one more return type of this application input box that I want to cover in this video. There are a couple of other types I haven't mentioned yet. If I click on the word input box and press F1 to bring up the help system, I haven't mentioned the number 4, which is a logical value or a Boolean value, which is essentially true or false. That's fairly simple to work with. And I haven't mentioned the number 16 either, which returns error values. So if your cell formulae contain errors like #NA, this number 16 can get your input box to return those as well. What I wanted to focus on here in this final part of the video is the number 64, which returns an array of values. Now we've created a separate video all about arrays, which is part of this series, this tutorial series. So I'm not going to mention explicitly everything to do with arrays. This is going to be the most complex example in the whole video, and if you're not confident with using arrays, then feel free to stop watching at this point. But what I'm going to do as an example is I'm going to get the user to pick a range of cells which are going to contain numbers. So I'm going to get these to pick a range of cells that contain the film lengths in minutes. And those values will be stored in an array, which I can then loop over and perform some sort of calculation. So all I'm going to do is convert the length in minutes to the length in hours by performing some kind of calculation. Then I'm going to take the contents of the array and spit them out somewhere, maybe in another column. I'll probably get the user to ask where they want to start returning the results to. And again, this is going to involve the use of using the application input box to select the original range of cells and also the destination cells. So let's get started in the VB editor by adding another new subroutine. So I'm going to say sub, I'm going to call it return array. To start with, I'm going to declare the array, which is going to hold the list of initial values that the user selects. So I'm going to say dim, I'm going to call it film lengths, then open and close some round brackets. That's what dictates that this variable will be an array, so it will be able to contain more than one value. And then we're going to set the data type to be as a variant. So it's an undetermined data type, essentially. It can hold any data type at all. Now this is an example of something called an undimensioned array, so we haven't specified how many elements it will hold or how many dimensions it has. And again, if you don't understand those terms, then the video on arrays explains all this in huge amounts of horrific detail. What I can then do is say film lengths equals application.InputBox, open parentheses, and the prompt will be something like choose lengths to convert, and the type is going to be equal to the number 64. So that allows us to store an array of values in that array. Just to quickly show you how this works, I'm going to step through the subroutine at this point, and while I do that, I'd also like to be able to see the locals window. So the locals window is going to display the contents of that array as we step through the subroutine. So if I use the F8 key to begin stepping through, I'll get to the point where I can choose my list of cells. So I'm going to select the full list of values there from D3 down to D15. When I click OK, in the locals window, what I can see is that I've got my film lengths array populated with a list of values 1 to 13, so that represents the number of rows effectively that I've selected. So you saw I selected essentially 13 cells, and 1 to 1, that's the number of columns that I've selected essentially, so I only selected a single column. If I expand that in the locals window, you can see all of the individual compartments that are part of that array. And if I expand one of those, you'll see finally the value that was stored in it. So you can see that the first value that I stored in the first element of that array is the number 143. If I switch back to Excel, you can see that that's the value in that specific cell. So back to the VB editor, what I want to do is just close the locals window for now and reset the subroutine. Now we need to be able to loop over that list of values in the array to perform some kind of calculation. To loop over the array, I'm going to need some kind of counter variable. So what I'm going to do is declare a simple loop counter variable. I'm going to call it loop counter as a long. So this is a long integer, so a very long whole number basically. Again, this technique is described in much more detail in the video on arrays, but once I've stored the array, I can say for loop counter equals. Now if I knew that the array was always going to contain 13 values and they were numbered from 1 to 13, I could simply say 1 to 13. But I don't know that the array will always hold that exact number. So what I'm going to do instead is use a couple of functions to find out the lowest number of the array and the highest number of the array. So to find the lowest number, I can use the lbound function. And the lbound function requires me to reference an array, so I can say film lengths. And I also need to say which dimension am I looking in. So my film lengths array contains two dimensions. Essentially they're the number of rows and the number of columns. And the number of rows was the first dimension, so I need to specify that I want to find the lowest number of the first dimension of the film lengths array. What I can then do is say 2 and essentially do exactly the same thing but using the ubound function, so that finds the highest number. So I'm going to say ubound film lengths and again refer to the first dimension. Hit enter a few times and I'm going to close my loop by saying next loop counter, and that section of code there will successfully loop through the entire set of values stored in that array. Now what I need to do is perform some kind of calculation on each of the values in the array. So in order to do that, I need to reference the correct element each time I want to perform a calculation. To do that, I've got to say film lengths. And let's imagine I wanted to reference the first element of the entire array. To do that, I'd open a set of round brackets and say 1, 1. So that's the first row and the first column. Now I don't know that I'm always going to be referencing the number 1 because I'm going to loop through the entire column of values. So instead of using the number 1 there, I'm going to replace that with a call to my loop counter variable. So because that will increase each time I go through the loop, that will make sure I process the entire column. I've only got one column in the array, so I can get away with always just using the number 1 there, because I've only selected a single column of cells. What I want to do now is make that equal to another value, so I'm going to change it to be equal to a calculated value. And the calculation is quite long and complex. What we're going to start with is by working out how many whole hours there are in that film length. So if I've got 143 minutes for the first film, the total number of whole hours will be 2. To calculate that, I'm going to use a function called int, which converts the result of the calculation into an integer or a whole number, so it will ignore any decimal places. And then the calculation I'm going to perform is to take this value as it is and simply divide it by 60. So that will return the whole number of hours. What I'd like to do then is add the word hours to the end of that, so I'm going to use the ampersand to concatenate a piece of text. And I'm going to add the word hours in a set of double quotes. The next thing I want to do is join on the result of the remaining minutes. So if the film is 143 minutes, I want it to say 2 hours, 23 minutes. So again, I'm going to concatenate another value to the end of that. In fact, I'm going to use the space underscore continuation character to carry on typing this instruction on the next line, otherwise I'm going to run out of space. So the next part is to concatenate the result of another formula, and that's going to be, again, the value of the film lengths for the element that I'm looking at, so I'm going to copy and paste that again. And then I'm going to use the operator called mod. Mod is short for modulus, and what that does, it returns the remainder of a division. So if I say mod 60, that will return the remaining minutes. So for the first film, that will be the number 23. Finally, I'm going to use another ampersand to concatenate on the word minutes to the end, and that will be the full calculation. So, having done all that, let me just quickly step through this subroutine while we can see the locals window again. So, display the locals window. I'm going to use the F8 key to begin stepping through. I'm going to select a range of cells, click OK, and then let's have a look at the values that are in this array. So you can see clearly to begin we've got the number 143 in the first element. As I begin stepping through, you'll see that this number here changes to the result of the calculation, 2 hours and 23 minutes. And as I go into the next one, that will change the next value to 2 hours 45 minutes, and so on and so on. So as I carry on stepping through, each of these values will change to their correct piece of information. So when we've got the values calculated, all I need to do now, if I stop the subroutine and close the locals window, all I need to do now is to spit the results of the array into the correct cells. To determine where the results will go, we'll ask the user to choose a cell. So just like we did earlier on, we're going to use a variable. I'm going to call this one result range as a range. And then after we've finished looping over our array, we're going to ask the user to set the result range by using an input box. So set result range equals application.InputBox, open some brackets. Now the prompt will be something like choose where to put results. Put results. And then the type, of course, will have to be equal to the number 8, so that it's a range of cells. So ideally what we're going to get the user to do is select a single cell. Let's say, for example, they've chosen this range of cells to convert, and they choose this cell to put in the results. We actually need to refer to the full range of cells that the results will go into. We can't get away with just referencing a single cell. So back in the VB editor, what we're going to do is reset the result range after the user selected a single cell. We're going to say set result range, if I can spell that properly, result range, equal to another range of cells, which begins at the result range. So cell 1 is going to be the result range. Cell 2 is going to be from the result range, offset a number of rows down and a number of columns across. Now the number of rows down that I want to offset from the result range, imagine the user selected cell F3 and they originally selected that entire column of cells to convert in the first place. So that's 13 cells altogether. We saw that we could use the ubound function to calculate the number of elements in the array. So if we say ubound of our array, that will allow us to offset 13 rows down from there. Now if we go 13 rows down, that actually takes us 1 row past the end of the list. So we're going to go essentially just subtract 1 from the result of the ubound function to return the correct range of cells that our answers go into. So back into the VB editor, we're going to offset this number of rows down, so I can copy and paste that, minus 1, followed by a comma, and the number of columns I want to offset will be 0, and then close round brackets for the offset function, and close an extra set of round brackets for the original range reference. So that will successfully, in fact, if I can bring this onto separate lines, I'm going to use the continuation character, use a space underscore, and bring this onto another line so you can actually read the whole thing in one screen width, and I'll do the same for the previous line as well. Let's do it like this so you can actually see the complete set of code. So that will set the result range properly. All we have to do now is populate it, and doing that is really simple. We simply say result range equals film lengths, and that will spit out the contents of the entire array into that range of cells. Having gone to all this effort, we should make sure that we actually run the subroutine to see if it works. So let's run it and pick a range of cells. I'm going to pick the full list of films this time, or the full list of runtime in minutes, and click OK. Then I'm going to choose to start putting the results in at cell F3. So if I click OK at that point, what should happen if I switch back to Excel is that that full list of cells gets populated with the answers of our conversion function. Just to run it again, just to show you that it will work with a different range of cells, if I run it again, and I'm going to choose just a small range of cells this time, click OK, I'm going to put the results in from, I don't know, cell G17 as it turns out, that's the cell I've clicked on, click OK, look at the results back again in Excel, and I'll see just the converted values for the small range of cells that I selected in a different output range. So, hopefully you appreciate that this was intended as a complex example for people who are familiar with or work with arrays already. And again, as I said, we've got a video that explains everything to do with arrays as part of this video tutorial series. Even if you don't use the array return type, hopefully you'll still think that the application input box is much more useful than just the original basic input box that you've seen previously. So that's how it works. Hopefully you found the video useful. If you've enjoyed this training video, you can find many more online training resources at www.wiseowl.co.uk.